Hi everyone, and welcome to the third video of this series in which we are learning how to model an end plate steel connection, which is one that looks like you see here. We are following a scientific article, which is this one. So the idea is to represent this physical model using a mathematical model of the type boundary value problem that we are going to later solve using the finite element method in Abaqus. Okay, so we are creating the model in ANSA, which is a preprocessor software. We're going to solve it in Abaqus, and we're going to post-process the results in MetaPost. I explained in details this whole structure that we're going to follow, the softwares that we're going to use, the version of these softwares in the first video of this series. Okay, so far we have created the beam, the end plate, and the stiffeners. We didn't create any mesh yet, but we are creating these faces with the properties that are going to be assigned to the mesh. Okay, so later I'm going to use, I'm going to focus some time to mesh these parts. But right now, let's just finish the geometric entities. Let's do a quick overview of what we have here in this database. So far, we have now 4 properties created. Let me maximize this. We have these 4 properties created. We have so far 2 materials, one for plates thicker than 16 millimeters and one for plates thinner than 16 millimeters. Oh, sorry, this one is for thicker than, and this one is for thinner than. I can even, well, let's keep it as with this name, it's okay. We have now 13 faces, these faces here. We have 72 cones. We have cyan cones and red cones. So single cones and triple cones. We have 36 hot points so far. You see where these hot points are positioned. One important information is that where we have hot points, we are going to have nodes of the mesh positioned. So you see that the hot points around these holes are positioned like this. We're going to have nodes at these positions. So it's important to keep the hot points well positioned around holes so that the quality of the mesh is going to be better. We have some centers. This center entity is just to position the center of these holes. We have these entities here. The visibility is not activated because it's not checked. If we check it, we are able to see this. I don't really use this entity, so let's uncheck this. We have 29 curves that we have created. Let's select all curves that we have created to create the geometries. If we'd like to, we can even delete these curves because we are not going to use it anymore, but let's just keep it for now. We have 18 points that was created to help us generate the faces. We have 4 ANSA parts so far. So everything is organized. We have 3 working planes. And actually we have this additional working plane that we have created to create the curves on this plane of the end plate. Okay, now the next step is to start drawing the column, I guess. Actually, you see that in the beam, we have these plates welded here. I guess I'm going to create these plates later because I need to adjust the length of the beam yet. So let's do this later. I'm going to create, this plate here. I'm going to create it later. So let's create the column. Here we have the length of this column. We need to sum up these dimensions. And we also have these dimensions here to be used for the column. So these dimensions are very similar to the beam. The difference is with the flange width, which is 250. So let's create this column. Let me think here how we can do this. Okay, so what I'm going to do here, well, we can do this in many ways. I'm going to show you one way. I want to use again the relative. So in the classic topo module, relative tool, select, for example, select this point and this point, mesomos button, and I want to create in the positive x direction, so 1 here in the x, and the distance is, well, I need to calculate this distance. The thickness of this end plate is 20 millimeters, right? What is the thickness of the flange width? Is 12. So I need to have this distance here. I know that you're not going to understand now, but we need to have this distance here equals 10 plus 6, half of the thickness of the end plate plus half of the thickness of the actually, there's one thing that is important here that we need to consider that I end up forgetting. You see that in the beam, sorry, in the column, this part of the column here is thicker. And actually the thickness of this part of the flange of the column is equal to 20 millimeters. We have this information written here somewhere in this text. Okay, so the thickness of the flange of the beam of the column is 12, but in this region here, 200 millimeters above this face and 200 millimeters below this face, the thickness is equal to 20. So this, let me zoom in, this thickness here is equal to 20, just like the thickness of the end plate. Okay, 20. And here we have it as 20. So the distance between the middle surface of the beam of the column flange and the middle surface of the end plate is equal to 10 plus 10. So in here we're going to have 20. So I'm going to create this with a distance equals 20 in the positive x direction. Click on OK. You're going to understand why shortly. Now these 2 points, we need to, this point I'm going to use it to create the line that is going to define the width, actually the line that is going to define, yeah, the flange width, which is 250. But right now, the distance, if we use the measure tool and measure this distance, we have it equals to 200. So the thing is, I need to move this point to the right, 25 millimeters, and this point to the left, 25 millimeters as well. I'm going to use the transform tool, move, select by entities, select this point, mesomos button, and then I want to move, translate, in this case, positive y direction, 1 here in dy, and 25 here. 25 plus, and finish. Now, this one, mesomos button, in this case, negative y direction, 25 as well, and plus, finish. Now, if we measure the distance between these and these, we have 250. Okay. Now, you see, in ANSA, sometimes this happens. What happened here? I'm not sure if it happened to you now. We have 2 different tools activated. One for move, one for measure. You see that in this part of the screen, we have the move tool and the measure tool activated at the same time. I'm trying to deactivate the move tool by clicking here, but you see that I'm not able to do this because the measure tool is activated on top of it. So I need to deactivate the measure tool firstly, and then the move tool. Or another way is to just keep pressing ESC, and you're going to deactivate everything. Okay, this is important to have good control over. Now, the next thing that I want to do is I wanted to move these 2 points in the positive z direction. And let's see how much. Let's see what drawing is drawing here. Okay, so these points are at this height, right? Let me see here. Yes, they are at this height. I want to move this height here. So how much is it? We know that the height of the end plate is, let me measure, 500. So half of this height is 250. 250, right? So let's do some calculation here. Let me open up calculator. So we need to get 265, no, actually 965 subtract by 250. And then we are going to have this height here, from here to here, as 715, right? 715. And then we need to sum this with 70 and, oh, sorry, plus 70 and plus 115, 900. Okay, so this height here is 900. What I need to do here is then I need to move these 2 points 900 millimeters upward. Let's use the move tool again. Select these two entities, middle mouse button, Z direction, 900 plus. And there you have it. Finish. Now I'm going to create a new curve. I am in the classic topo module. Create line from here to here, middle mouse button. I'm not able to see this because I need to activate the visibility of curves by checking this box. And now I need to copy this in this direction, and the height of the column is the same as the height of the beam. Section depth is 300 for the beam and for the column. We have calculated that we need to have a distance equals 28a between these lines. So I'm going to copy this entity, middle mouse button, in this case in the positive x direction, by 28a plus no offset in part, same part, and click on OK. Finish. And now I need to create a new curve from this midpoint to this midpoint. Middle mouse button and close. Okay, now we have the section of the beam, or actually of the column, generated. And I need to extrude this section in this direction. So let's calculate the distance. We need to sum up all these. So it's going to be 115 plus 70 plus 965 multiplied by 2. 2,300. So in here, we're going to use the tool extrude inside the surfaces group, extrude, left click and hold until you see these options, and then select extrude here. And then in extrusion profile is going to be create a box selection to select all these curves, middle mouse button, and now this is selected, and now we need to select direction profile. Use vector in the minus Z direction. Distance is 2300, right? Yeah. Middle mouse button, and then click on OK. Now it's asking a property for us to assign. We can assign this to the beam web. Double click here. And then the part, let's create here a new part. Create a new part. And by the way, when I used the extrude tool, you're going to see that we're going to have some things here in options list. And then in part and property, you should select ask always, so that you're going to see these options here. Okay, so if in your case you're not seeing these options, you should do that. This part is going to be named as column. Oh, column. Double click on this one. And then this is for this face. So it's going to create 3 faces. Let's assign all faces to beam web, and then we're going to adjust this property later, and this part. Beam web again, and column part. And then it created these faces. Let's close these. I'm going to, well, for the first time, I'm going to show you how to isolate entities. I have these tools here that you see, these buttons. And then these buttons are related to visibility of entities, not actually related to visibility, but related to how we isolate or hide or things like that. Okay. We are going to slowly learn about these tools. Right now, I'm going to show you the isolate tool, which is named as not here. So left click to activate it. Whenever we activate a tool like this, we can select the entities that we want to isolate, but to select it, we have the selection filter, which is related to these buttons here. So right now, we are selecting by property ID, PID. So for example, if I select this, I'm going to select this whole property, which is not what I want, because I'm going to end up selecting this property here as well, since I have assigned the property beam web for the column. So that's not what I want, so I'm going to click here on this button to show all. Now everything is going to be visible again. I'm going to activate again the not function. In my case, it's already activated. If I click on this drop down list, I have other selection filters. So I can select by material, for example, which is not a good idea. By parts, well, maybe this one is a good idea. PID region, macro area. Anyways, I'm going to slowly explain what is macro area, PID region over time. Okay, whenever we need to use one of these, I'm going to explain the meaning, instead of keep explaining everything all the time. So in this case, the most suitable one is by part, because I created one part for these 3 faces. So left click here, and then I have this whole part selected, and middle mouse button to conclude. Looks like we have this face assigned to this part as well. Let's see. No, it's not. Let's click on show all again, and then select activate not function, selection filter part, this one, middle mouse button. Okay, now this worked. Now again, I want to paste, I need to project this single cone to the flange of the column. So project, activate, paste here, this cone, middle mouse button, this face. This cone, middle mouse button, this face. Now let's adjust the properties of these. To adjust the properties, go to property list, and then I need to create some new properties. Actually, you know, the web thickness and flange thickness is the same for the beam and column, but I'm not going to really use the same property because I need to have this separated, just for maybe when we are selecting the entities and things like that. You're going to understand it later, why I don't want to keep everything in the same property for different parts. So what I'm going to do here, the beam web, I'm going to right click and copy, and then instead of naming it as beam web, I'm going to name it as column web. And I'm not going to change anything because the thickness is the same. So click on OK, and here we have it created. I'm going to do the same thing for beam flange, copy, and name it as column flange. Now we have these new PIDs created, but it's not assigned to anything. You see this lamp here? You see the color of this lamp? It's white. This means that it's not assigned to anything. When the lamp is in this color, brown, no, it's not brown. It's I forgot the name of this color. Gray. When it's gray, it means that these properties are assigned to some entities, but these entities are not visible. So we have the gray color. And when it's this color, beam web, this means that these properties are assigned to some entities, and some of these entities are visible, so it have on, and some of these entities are not visible. Okay. Anyways, we need to assign these two new properties to these faces. So close this. Let's use the set PID tool again. I want to select by macros shells. So faces are also named as macros in ANSA. Select this one, this one, this one, and this one, middle mouse button, and then this is column flange, double click. And then this one, middle mouse button, and this is column web. And that's it. Okay, now let's click on show all, and here we have the beam created. Now this is starting to look great, right? We have a few things to create yet. Let's see here. Now let's do one thing here. You see, the thickness of the flange in this region is different. So we need to create a different property for the thickness of the flange of the column here. We have a distance here from here to here equals 100, and from here to here equals 100. Let's consider until here. You see that we have this decreasing thickness, but let's consider the thickness until here equals 20, and then from here we consider the nominal thickness of the flange. Okay, so we're going to learn about a new tool here that is very important. Let me think here how we can do this in the best manner. Okay. I'm going to use again the relative tool for points. Select these 2 points, middle mouse button, positive z direction, 100 distance, click on OK. Now I'm going to use again the relative tool, select this point, middle mouse button, and positive x direction, and a distance equals 100. Just follow what I'm doing. You're going to understand what I'm going to do here. I defined 3 points that defines a plane, right? With 3 points, we can define a plane. I'm going to use a tool here that is inside the faces group. Let me see. Plane cut. Yeah, I guess it's the plane cut. Yep. The plane cut tool inside the faces group. Left click here. If you don't see it, you can check other options here. Left click on plane cut, left and hold, and then select a single. And then here, let's select these 3 points to define a plane. You see now it defined this plane. Middle mouse, actually we don't need to click middle mouse button. Now it's saying confirm or select specific faces. Get a view like this using the control and left mouse button together, and then create a box selection with the left mouse button to select all these faces, and then middle mouse button to confirm. Now you see that we can press ESC to deactivate, and you see that we have these new double cones created. These are double cones because, for example, this cone is connected to this face and this face. So it's connected to 2 faces. And these cones split the flange faces into these regions so that we can assign a different property for these faces here, for example. But I need to split below here as well. So let's do this. Again, relative, these 2 points, middle mouse button, negative z direction, 100, click on OK, click on this one, middle mouse button, x direction, 100, click on OK, then plane cut, single, select the 3 points, and then position the camera like this, create a box selection to select the faces. And by the way, yeah, okay, it works on both ways. So create a box selection like this, and then we have all these faces, middle mouse button, and then we have the double cones showing up here as well. Now the next step is to define a different property for this face and for this face. That's why we have splitted the column like this. Okay. By the way, when we do this, it doesn't mean that the column is going to be splitted physically. Since we have this a double cone, this means that we have a continuity in the mesh between this face and this face, for example. Okay. So the column is going to be continuous. That's not going to be physical division here. All right, now let's go to property list. And since I'm going to use the same thickness of the end plate and the same property and the same material assigned to this, I'm going to copy this property of the end plate, copy, and then I'm going to rename it as column flange end plate region, for example. And then thickness is 20, the material is with ID 2. If I press F2, I see that this is the material for thickness thicker than 16. Click on OK. Element type is S, everything is correct, click on OK. Now we have this new property, it's not assigned yet to anything. So close this, go to set PID, select this face, middle mouse button, and then select this new property and close. Now this is correct. Now the thing is, I guess that you understand now when I created from these points a point distance by 20 millimeters, right? And then I moved these points to this position. I'm talking about these 2 points. I did it because now the distance between this face and this face, let me get here the measure tool. Let's select this face and this face. This distance is equal to 20 millimeters as you are seeing. And this is very, very important because we're going to have a contact defined between these faces. And we should not have any kind of penetration between the faces because we are going to face convergence issues. And we should also not have any gap between the faces because it's going to be a little harder to make this model converge. Okay. So when we have you're going to see that when we mesh these, we can visualize the thickness And you're going to see that we have, when we have the thickness considered, these two faces are going to be in contact. Well, let's save this file, save, and let's continue working. Let's see, the next thing that I'm going to do is to create the column stiffener. Well, for this one, it's going to be very easy. You see that these stiffeners are in the same height of the beam flange, right? So what I'm going to do is I'm going to use the beam flange to create a cut like this on the column using the plane cut tool inside the faces group. So plane cut, left click and hold, single. To define the plane, we are going to position the mouse. Actually, we can select this hot point, this one here, and this one, for example. Now we have this plane here. Now to select the faces, position the camera like this and create a box selection like this. Be careful, because I want to select only these faces here of the column. Don't select anything from the beam. Now we have these faces, middle mouse button, and now we have these lines, these double cons. We are going to use it to create the stiffeners. Let's do the same thing here below. I have the plane cut single tool activated yet, so select this point, and this point. With 3 points, we define a plane, and then position the camera like this and select these faces here. Middle mouse button, and now we have this. Now let's press ESC, and we're going to use again the new faces tool. You see that we always use the same tools. So new planar, because it's going to be planar face, and to create it. And by the way, in here, let's select ESC always and ESC always, and then select these, and this. Middle mouse button, and then let's create a new part, and this is going to be the column stiffener, because we have an E and ER. Double click, and then the property. Let's see the thickness of this. I guess we have this information here. Stiffener. So the column panel zone stiffener thickness is 12. So let's create a new property. You see that the beam flange has this thickness as well. So let's use this property and copy it. And this is going to be the column stiffener 12, and click on OK. So double click on this new property and accept this face. Now we can continue creating the faces. We have this face that is positioned here to this part and this property. Okay. And here, the same thing. This part, this property. Okay. And in here, this part, this property, and okay. And we are done. It was pretty fast. Okay, guys, we are going pretty well. We are actually almost finished with the geometry generation. Let me think here. What else we need? So you see that in this drawing we have these plates here as well, and these ones, and these ones. Let's create these now. Okay, so here we have where this plate should be positioned. We're going to create it using the same strategy. We don't have information about the thickness of this plate, so let's consider the same thickness of the column stiffener. Let me think here. One way we can do this. Well, there is one interesting way we can do this. It's a different manner. Obviously that we can create 3 points in this height and create a plane cut just like we did and create the faces. Or we can copy these faces here and copy it in this direction. So let's use the transform copy tool, select entities, select this face and this face. Middle mouse button, and then you see that I have the copy function activated here. I want to move in, well, let's define the direction by selecting this hot point and this hot point. So it's the positive z direction, but it's not this distance here. Let's calculate this distance. So it's going to be this distance minus this one, because what I actually want is this distance here, right? So I need to get this subtract by this, and that's it. Let me do this. So 965 minus, well, this height here is half. Oh, actually, let me think here. Yeah, it's half of this height of the beam. I have this height here, 288. So minus 288. Okay, so 677. Let me see one thing. Yeah, I guess it's all right. 677 plus, and then in here it's important to set up this correctly. So for PID, we can no offset. This means that these plates are going to have the same PID as these, or auto offset. Auto offset, it means that it's going to create a new property, and current property is going to select, well, no offset and current property, I guess it's going to result in the same thing. Actually no. Let's select current property. I want to keep it in the current property. Set could be none, and property could be the same part. These new entities could be positioned in the same part. Click on OK. It's not working. Let's select here no offset and click on OK. Yeah, now it worked. You see that even though it's saying that no offset creates another property, I don't know, but this keeps these new entities in the same property. You see, it's in the same color. Usually I use the no offset. And then click on finish. And here we have it. But notice that we have these single cones around. This means that these are not connected yet. Compared to what we have here, we have cyan cones here, meaning that these cones are connected to 3 faces at least. This is what we should have here. So to fix this, I'm going to use the project tool, activate paste here, and then select this middle mouse button and this. And then this middle mouse button and this face. And then this cone, middle mouse button and this face. This one, middle mouse button and this one. And there we have it. Let me see if there is another single cone here. To be sure that everything is pasted, it's better to use the topo tool in this case. Let's use the topo tool, create a box selection, middle mouse button. The software is going to recognize every cone that is too near to each other, and it's going to automatically paste them together. So now I'm sure that everything is connected here. Now let's check one thing. If we go to this drawing, we see that the distance that we should have from the top until this face is 70 plus 115. Let's check this. 70 plus 115, 185. I'm going to get the measure tool and measure these. Looks like we messed up somehow, or actually I messed up. But this is easy to fix because I just need to move these faces in the upward direction. So I should have 70. Let me check this dimension here from this plate to this middle line. I need to create a point here passing through this middle line. So I'm going to use a new tool. Let's learn about a new tool. In the classic topo module points group, we have this to create a point on COG. Left click here and hold, and then you're going to see these options. I want to select points. Now I want to create a midpoint between this point and this point. Middle mouse button, and there we have it. Now use measure tool, measure from this point to this one. 821. And I should have 965. I don't know. I messed up in the calculations. So yes, we should move this in the upward direction. So let's select here, and let's store this measurement. Close. And now we have this here. Well, I should have this distance as 965. And what I have is 821. So subtracting both, I have that I should move this 144 above. So I'm going to use the transform move tool. You see that I'm doing things faster now because at this point, you know well about these tools. I'm going to select these faces, middle mouse button, and I want to move from here to here. But I don't want to move this whole length. I just want to move 144 plus and finish. The thing is, it didn't move these cons together, so I'm going to actually Control Z, and I'm going to check if I can move. Yes, I can select these cons too. So I'm going to redo because I used the undo tool, that is Control Z. Now I'm going to use the redo. And then now I want to erase these double cons because I don't need to have this division here anymore. And to do this, let's learn about a new tool. So it's good that it didn't work at first because then we can learn about new important tools. And this tool is very important. So in the faces group, we have this tool here, cut, activated. And then this cut tool is used to create some cuts in the faces. So you don't need to do what I'm going to do here. We can create a cut from here to here. And then it creates this cut here. But that's not what I want. I want to eliminate a cut. To do this, I need to use the right mouse button. So to create a cut, I use the left mouse button. So left mouse button here, left mouse button here, and I create the cut. To eliminate a cut, I need to use the right mouse button on a cut, like this. So right mouse button here, 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 and here. Right, now I need to project these cons again. So let's do this, project this one here. Actually, we can use the topo tool, select everything, middle mouse button. Oh, and here we need to project it anyways, because we don't have another con in this flange. So project these in here, these in here, these in here, these in here. Now just use the topo tool just to guarantee, and that's it. Okay. Now let's, for example, measure this 185, which is the sum of 70 and 115. This is correct now. Now I need to copy these 70 millimeters upwards. So transform, copy this entity and this one, middle mouse button, copy, this direction from here to here, but 70 millimeters plus no offset, so that the new entity is going to be in the same property, same part, and click on OK. Finish. And now project this in here, this in here, this in here, this one in here, and this one in here. Just let's use the tuple just to guarantee. All right. Okay, this is starting to looking great. Let's now copy this to the other side. We can use a new tool that is going to be interesting. So what we can do here. Oh, sorry guys, someone arrived, and let me close the window because my doggy is going to bark. All right. So to create these stiffeners, because in here these are not actually stiffeners. Well, this can be thought of as stiffeners, but this is going to be used to fix the beam, the column. If we go to this drawing here of the physical model, we have these stiffeners here, you see, on both sides. And this is the region that I'm going to fix this column. And that's why he put some stiffeners here. So we need to copy this to the other side. And it's going to be interesting to learn about a new tool, which is the symmetry tool. So we're going to copy, and don't do what I'm doing now, I'm just showing. And in here we're going to use the symmetry option, and we can select a plane to define the symmetry plane in many ways. So first of all, before we using this tool, we need to define the plane. So let me close here. Let's define the plane. I have this point here that we can use for this plane. Let's create two more points, because we need 3 points. So on COG of points, select this point, and here we have this new point. And on this side, this point and this point, mesomorph button, and we have this new point. So the thing is, we have these 3 points that we can use to define a plane, which is going to be the symmetry plane. Okay? So let's move up. Let's use the transform tool, copy, select these, rotate, select these and these. Be careful to select the correct entities. Middle mouse button, and now guarantee that you have copy here, and then let's go to the symmetry tab, and let's select a plane by selecting 3 points. Zoom in here, select this point, rotate, and this point. Now, click on apply, and for PID, no offset, so the new entities are going to be in the same PID and same part. Click on OK, and there we have it. So we've applied a symmetry around this plane here. Okay, so this is a new thing, it's a cool thing, I use it a lot. Finish and close. All right, now let's just do the projections. We can do for 2 cones at the same time, so select these 2, middle mouse button, and this face. These 2 and middle mouse button, this face. Let's use the tuple tool just to guarantee middle mouse button. Yep. Now this looks really great. Let's take some measures. Yep, this is all right. Let's save it to guarantee that we don't lose any information. Okay. Now the last thing that we have to create in this module is these 3 plates here. Let's see in the physical model what we have. Well, in the physical model, looks like we have this plate here, right? And we have this tool here with a probably hydraulic actuator to to apply the force. And this tool is attached to the column as you see here. But instead of representing this whole structure, what was done here in the numerical, in the mathematical model, was something like this. Looks like he created two plates on both sides. Oh, sorry, this is for the column. Looks like he created 3 plates. Sorry guys, I'm starting to get tired because I'm recording this class for a very long time. Because I recorded 2 classes together. So we need to create these 3 plates. Looks like with the same thickness. It doesn't say the thickness here in this article. So let's say that the thickness is the same as the thickness of these plates here. Okay. So the most important thing is that we respect this distance of 1200. This distance looks like it is from this face to this face. So let's suppose that, let me get from here. Looks like it is from this face here, right? But just to facilitate, it's not going to really make so much difference. Let's make it from the middle face until this face here. Okay, remember that what we have in our model so far is the middle face, right? We have the middle face, and then, but in here looks like it's getting from this face. Well, let's just round it up and let's say that it's from the middle face. My point here is that let's suppose that this stiffener is positioned here. Okay, so I'm going to use the measure tool, dynamic selection. I'm going to select this hot point, and I want to check the distance between this hot point and one hot point that is part of this face here, of the flange of the column. Select it. And then I have this distance here, but that's not what I want to know. I want to know the x component of this distance. So click on the store, and then we have this information here. And the x component of this distance is 1020. Sorry, 1220. So this means that I need to create that plate a distance equals 20 millimeters from this hot point. So the distance between this plate and this face is going to be 1200. Okay, I guess you understood. Let's double click here and delete this measurement. And I want to create, I want to use the copy tool. Just follow what I'm going to do and you're going to understand. Copy these 2 points, middle mouse button, and copy in the, let's use the translate option, copy in the positive x direction, 20 millimeters. Click on OK and finish. There we have it. Now I need one additional point, so let's use the relative tool. I am in the classic topo module. Select this point, middle mouse button, positive z direction, and could be any distance here, 50. I'm defining here 3 points to create a plane. And then plane cut, single, select this point, and this one, middle mouse button, and then click on yes. Now it created this double cone, and now we can use the new faces tool, planar, select this one, and this one. And then in here, in part, ask always, and property, ask always. Middle mouse button. For the part, let's create a new part named beam stiffener. Double click on this new part, and for property, we can get the column stiffener property, copy, and then rename it as beam stiffener. We can use the same thickness. We don't have information about this thickness in the article. Click on OK. Select the beam stiffener and click on OK. There we have it. By the way, okay. Now let's create on the other side. Select these three cones, mesomorph button, beam stiffener, click on OK. All right, now this is the meso one. Looks like it's a thicker one, right? And we have these other two. But looks like in this module, the thickness is the same. It's not really going to make any difference. We don't have the information of this distance here, right? This distance. So let's just assign a distance here. Could be 70, just like what we have here. So transform, copy, select these two faces, mesomorph button, and I want to copy it in this direction defined from this point to this point, but the distance is 70 plus no offset and same part, click on OK and finish. And then again, select these two faces, mesomorph button, from this to this. So I'm going to copy in the backward direction by 70 as well, plus OK and finish. And close. All right, now I need to create the projections here. So project here and project here. And let's create this projection here as well and here as well. The thing is, now we need to extend this beam so that it's at least a little longer. Let's see here. You see it's a little longer than it's passing through the last stiffener. So how we are going to do this? Well, there are many ways we can do this. Let's think here one way. We can create a new face, planar, and then let's use this. And by the way, let's do one thing here. Ask deactivate visibility of curves, because we have some curves here. New planar, and then let's select these. Let's see if it works if I select these and these. Mesomorph button. The part could be the same part as the beam, because it's going to be a continuation of the beam. Instead of selecting from here, I can select here, and then it's going to select the beam. Mesomorph button. And then the property is the same as the flange. So select here, and it's going to select in the list the beam flange, mesomorph button, and click on OK. Yeah, this works. Now, let's create a new face from here to here, mesomorph button. The same part as beam, mesomorph button. Same property as the beam web, mesomorph button. Click on OK. Now, select this one, this one, this one, and this one. Mesomorph button. This part, this property. Okay. Now let's just connect some things here, because you see that's not connected. Let's firstly start with the topo tool. Topo, create a box selection, mesomorph button. Yeah, it didn't really connect. So we need to project. So project this mesomorph button on this face. Now it's connected. And also here, this and here. Now you see that we have this double cone. We don't need to have it. So use the cut tool and use the right mouse button to eliminate these cones. Look that when we do this, these cones transform from yellow to this color here. I don't know what color is this. Maybe orange. Yes, orange. This is just to, well, this is actually not a cone anymore. This is just to show where we had a cone that we eliminated. So we can restore this cone later. Okay, but this is not anymore a con. It's only here, so we have as something that we can use later if we want to have it back. Well, in this module, we have an extension of the beam in this direction, but we don't need to really have it here. Okay, it could be like this. This middle one, as you see here, is going to be the one that we're going to apply a load or a displacement. So you see this stiffener here, this one is going to be the one that we're going to use to apply the load. So we can use, if we go to the physical model that we have here, the load is applied here, as you see here. Okay, so we can have, for example, a distributed load in this area, in this top area, or anyways, we're going to define it later. But this region is going to be for load application. This region here and this one is going to be to fix this structure. All right, so this video is long enough. The good thing is that we have finished creating all geometric entities. Let's not forget to save this. And then in the next video, we are going to start meshing these parts. And it's going to be pretty easy, as you're going to see. And, oh, there is one thing here. We need to create these holes on the beam, on the column flange. Well, it's pretty easy. Let's do this in this class yet. It's pretty easy to do this. Let's use here in the classic topo module, the project tool again. Be sure that you have here the type normal. So this projection is going to be in the normal direction. And in this case, deactivate the paste option. And then select this and this cone and this one. Let's select the cones of the holes of the end plate. Be careful to, well, be careful because you can't select wrong cones. Middle mouse button, and then select all these faces here to create this projection. Yep. And now middle mouse button, and there we have it. This is perfect. Now we can use the delete function, zoom in and delete all these. So left click to select it. I'm going to select all these faces that I want to delete, and middle mouse button, and OK. Now we have it there. All right, now we are finished. In the next video, we are going to mesh everything, and we're going to start setting up this model. And you see that up until now, we didn't really use many things related to FEA theory because we are generating a geometry here. So we are actually learning more, ANSA features, ANSA tools. But in the next video, we are going to start actually defining the mathematical model. Actually, we started because this is the definition of the domain of the mathematical model, right? This is part of the definition. But in the next video, we're going to start to see something more technical related to FEA theory. Okay, so save and see you in the next video.